All right, guys, good morning. Today we start to review for your final exam, which is just over this last unit, Unit 11. So that's all you got to worry about is all the trig things. Today I don't want to spend too long reviewing. I want to go through the basics of opposites and adjacents and y's and x's and r's and radians and degrees and all that stuff from the front end of the unit. Tomorrow we'll review the graphing part of things, graphing sines and cosines and cotangent and all that kind of jazz. And then I'll start to check notebooks today, and tomorrow, it'll probably bleed into tomorrow. Probably won't get all done today. But that's basically what your plans are. You still have homework to do over the inverses stuff, 11.7, that'll do tomorrow. So be working on that, and I will also hand out your review assignment today. Start hacking away on that. That'll be due when you take your final. So whenever your final time is allotted, that's when you need to show up with it, turn it in, and that's basically it. Okay, work today. Let's just go over some basics again. In terms of the opposite, adjacent, and hypotenuse associated with any angle, define all 6 trig functions. Well, should know the acronym at the very, very, very bottom level of this entire unit is, it's all running off this, SOHCAHTOA. So if you know that, you got 3 of them right there. Sine, according to the acronym, is opposite over hypotenuse. So write that down, opposite over hypotenuse. Cosine, the ca part, is adjacent over hypotenuse. And tangent, according to the acronym, is opposite over adjacent. So those 3 should be gimmies, pretty much, because you got an acronym for it. You got to know which one is flipped to give the other ones. So on the test, I will put these in order, but I'll probably put them down here. I'll probably put cosecant, secant, and cotan next. And it's your job to know I'm doing the same order, sine, cosine, tangent, kind of things. So flipping sine is what gives you cosecant. Got to know that one. You know that, that's easy, because sine's opposite over hypotenuse, so I guess cosecant is hypotenuse over opposite. Same thing flipped. Secant is cosine flipped, so that'd be hypotenuse over adjacent. And cotan is by definition tan flipped, so that'd be adjacent over opposite right there. And that's it. That's all you got to know for basic SOHCAHTOA things. Questions on that? Pretty straightforward. Now, one thing that was deficient in this unit is you never actually use this stuff to solve problems. So I do want you to solve a few problems using SOHCAHTOA on your test. And they're very straightforward. I'm going to model how to do them right now. Number 2, write down this triangle. Okay. Got a 27-degree angle on it. The right triangle. Make sure you're always using SOHCAHTOA with right triangle. We haven't done anything besides right triangles this unit, so that's pretty good. This triangle, number 2, has one side that you know and one side that you want to find. So if you are solving a triangle or trying to solve for a missing side, here's how you go about doing it. You use the SOHCAHTOA. We haven't actually applied it. We're going to apply it right now for problems. What trig function is involved with these 2 sides? You need to tie a side you know, something you do know, the side's 10, right? To a side you don't know, which in this case, we're trying to find x. Now, for this 27-degree angle, what is side x? It would be the opposite, wouldn't it be? And this side would be the adjacent, right? So what trig function pops to mind when we're talking about opposites and adjacents? Tan, right. So if you were going to solve this problem, you'd say tan of the angle, so tan of 27 degrees, is by definition the opposite, x, over the adjacent, 10. And then if you actually want to solve for x, all you'd have to do is why is x out by itself? It's divided by 10, right? So we'd multiply both sides by 10. And then you have x by itself. And then you have 10 times tan of 27 degrees. And then you get your calculator out and you actually type it in and you see what you get. So let's see what we do here. This is how you solve practical problems. It's that easy. I wish I'd given you more throughout the unit on this because it's kind of the point too. It's not just to write ratios of sides, but actually solve problems. Make sure you're in degree mode. Should be. I don't think we've had a reason to go outside of it. You get about 5.09, somebody? I'm getting 5.09. Anybody else getting 5.09? Okay. About 5.1-ish, 5.09, whatever you want to call it. That's good enough for me. So this missing side x is about length 5.09. Does it make sense how we thought that through? Yeah.
On the test or anything, do you want us rounding?
I would. I'm not going to pick on you too much, but don't round to like 5. You always give me 2 or 3. If you give me 2 or 3, you're safe.
Say on the test, probably.
I won't even say on the test. I'll just say, just give me the answer or something like that. But just give me 2 or 3 always. You're never going to be fine. I'm really looking that you did it right. I'm not going to pick on you for the rounding, unless you round crazy. Don't round to 10.
Yeah.
That's insane. You know, use common sense on the rounding. Okay, good questions. And then there's another one, number 3. So we're gonna do the same thing again, practice this skill. Really shouldn't be harder than this. So solve for all sides, it says. Oh, we didn't do that in the last one, shoot, darn it. How would you have found the other side, by the way? Okay. If you have 2 sides of a triangle, what theorem could you have used to find the third? Yes, don't forget about that little trick too. So we'll do a completion on this particular problem. Forgot to do it last time. Whoops. That's okay. You got a 37-degree angle inside of this thing. You got the opposite side of it is a length of 37. And the side you want is the hypotenuse, which is x. So again, your logic is, whenever you're solving these things, you start off by saying, okay, what side do I have and how do I connect it to the side I don't have? So here's 37. That would be the opposite side. And this is the hypotenuse, right? So if I want to solve this, I need to play with O's and H's. Sine, I agree with sine. So we jump in with sine. It's always sine of the angle. So in our case, sine of 37. And that'd be opposite, which would be 37. And divide by the hypotenuse, which is x. Okay, so we have this equation. Now this one might be slightly trickier just because there's a divide by x. And I think that we usually freak out when the variables are on the bottom. But how do you get rid of dividing by anything? Multiply by it. So if you don't like it, divide by x. Okay, who cares? We'll just multiply both sides by x. That'll undo that division by x. So it's better. Now I don't have any division in there. That's something. Now I got x times the sine of 37 is 37. Got rid of that fraction, but I don't have x by itself. But x is times sine of 37. So how do I undo multiplying by sine of 37? I can divide by sine. Yeah, exactly. So that's all there is to it. So this answer is going to divide both sides by sine of 37 is 37 over sine of 37. So you type that in your calculator. I'm getting about 61.48. Is anybody else getting 61.48? So there's our solution. 61.48-ish, something like that. And we're done. Do we need any more lessons over that? I think that's a pretty straightforward skill. Would you kind of agree, solving a triangle? Okay. Just remember, when you look at it, tie the 2 sides together, the one you know and the one you don't know. Now we're not done because the directions said to find all sides. So if this side is about 61.48-ish, how can I find the third side? Well, I could do Pythagorean theorem. That's nothing wrong with that. Or we could use another trig equation. Doesn't really matter to me. What do you feel like? You want to do Pythagorean theorem or you want to do trig again? What do you feel like? Oh, okay, let's do that. Let's be careful with it then. Pythagorean theorem. I'll give this a name. Let's call it W for no good reason. You know, whatever you want. So Pythagorean theorem says that the square of the 2 legs added together, 37 squared, plus w squared is the hypotenuse squared. Make sure the hypotenuse is always the c thing in your a squared plus b squared equals c squared. So if you move things around, square them. If you can go solve for w real quick, I'll do it too. We'll see if we get the same thing. Square the 61 thing, square the 37 thing, get the squared thing all by itself, and then take a square root. Anybody want to be bold and tell me what they got? I got the same thing. About 49.1-ish or something like that, depending on how you round it along the way. So why you don't want to round too much as you go. You know, if you rounded this to 61, the more you round in your work and then you use it, the more your answer gets off and off. So try not to round too much as you go. Cool. So this side's 49.1. Now, just for extra credit, if I want to solve this triangle, which means find everything, there's only one thing we don't know in this triangle. Do you see what it is? This other angle, right? How could you find this angle? Well, you could use inverses, but do you remember what all this?
Triangle sum.
They add to what?
Triangle sum.
Triangle sum. What's that called? What's that called? I don't know.
Doesn't it equal 180 all angles?
Is that what that's called?
Yeah.
I don't know. That sounds right. That sounds like a fancy thing math people would say.
Teach us what they were all called.
Good for her. Good for her. Triangle sum theorem. Is that what it's called? Ooh, that's fancy talk. I'm going to learn that. Okay. Triangle sum theorem. All the angles add up to Okay, so let's see. 180 minus these two would be that then, wouldn't it? So I'll do 180 minus 90 and minus the 37, and then I get 53. Do you get 53?
Yep.
Sweet. Triangle sum theorem. Interesting. Ooh, I'm learning. I like to learn.
Might have extra cards.
Good.
Give us cards.
Nah, I'm good on that. Thanks. I'll just try to learn the buzzwords just like triangle sum theorem. Okay, so there you go. All right, LGs. Starting to review today. Starting to review. Got to have our basics down. Going over basics today.
You checking your notebooks?
I'm going to start doing that after we've done our little spiel. I might not get to all of you today, but we have Thursday and Friday too, so we will get them done.
Oh my gosh,
So,
aggressive.
the short authority rules, but I saw right now.
You only have like 5 minutes for papers. But yeah, you know.
Like for this one, I wrote down that we're just starting the review packet.
Yeah, you gotta write down the whole thing.
I just kind of like usually.
Especially the day I'm checking them. Don't paraphrase the day I'm checking them. I know what we just did.
No,
It was like 5 seconds ago. I'm like, I know what we wrote down.
Myers. I usually just like flop off like students. I drop off like 1 or 2 words at a time.
I bet you I could predict exactly when this class writes it all the way and who doesn't. I bet I get a good shot of that. I don't know. What do I know? All right. So reviewing the stuff at the front end of the unit today. Start on warm-ups and learning goals. Don't forget 11.7. Still, you have an assignment out there for reveal. That's due tomorrow, either on paper or online. Either one's cool. This review assignment is not insanely long. It only has 35 problems, and you got like 5 days to get them done. So that's a long time. So I want you to go nice and slow. Make sure you got all your concepts down. Your final exam will be about this length, maybe a little shorter, probably 25 questions or something like that. Something more, slightly more manageable. Yeah.
So the homework that we just did, the 11.5,
Yeah.
will these problems be on the test?
Very easy versions of them. Yes. I'm not
Okay.
going to make you graph really complicated cosecants or things like that. But if I say cotan of 2x, something simple like that. No numbers in front, no movements, no weird stuff. I do want you to be able to graph the reciprocal ones, the basics. I'm going to keep them as simple as humanly possible, though. So. All right. Well, let's see what we got on the plate then. So, like I said, notebook check today. This is S2.F, as it says on the top of your thing. It's on Google Classroom too if you need it in your remote. And that'll be due when you take your final. This is it. Everything on the board. This is the whole rest of the year. You get all 3 of these done and you study for your final, you should be complete with everything, which is great. Of course, you still got extra credit opportunities too. Do encourage you to do that. The extra credit worksheet out there is exactly what we just practiced in the warm-up. Solving triangles and missing sides. So it'd be good to do that, not only because it's extra credit and it'll go to your test scores, but also help you practice for the test. And I will put a few of those problems on your test. All right, here we go. Ready to review? Unit 11, starting off way back in the day, they just talked about how to even measure angles. By now, it makes perfect sense. We've done it 1,000 times, so it's automatic. But remember, we do things in standard position. Standard position means whenever you measure an angle, you start at where? The positive x-axis, correct? And you rotate counterclockwise for positive. If it's a negative angle, you rotate clockwise. Normal kind of stuff like that. This is where he starts called the initial side, where it ends at the terminal side. Do we ever use those terms after that? Not really. So you don't need to worry about that. I'm not going to sit there and say, where's the terminal side? But in case they ever bring that up, you're cool. And like I just said, positive is counterclockwise and negative is clockwise. Okay. Now, coterminal, remember what that one means?
You can add or subtract.
Add or subtract all the way around. Yeah. So if I give you something, and this is very important, people do this all the time on their review. I'll give you something in radians, and then you'll tell me two coterminal angles in degrees. I don't want that. If I give you radians, give me two coterminals that are in radians. If I give you degrees, give me two coterminals in degrees. Okay, so you add or subtract all the way around. Now, if it's degrees, you're right. How it's 360 all the way around, right? You take your angle, you add 360, you take your original angle, subtract 360, you're good. What's all the way around in radians? 2 pi, very good. So you'd have to add or subtract 2 pi. That means you have to get a common denominator probably and do some fractional work, but that's basically all there is to that. So coterminal angle just going around again. Don't forget how to get between the two systems. This might be your lifesaver. Plus, I am going to ask you questions about converting between the two. So if you have something in radians and you really don't understand it, and nor should you because you're pretty new at it, you can always convert it over to degrees by this conversion that pi radians is the same thing as 180 degrees. And if you need to convert, you multiply by either pi over 180 or 180 over pi. How do you know which one to multiply by? You want the thing on the bottom to cancel with the thing you have, right? So if you had degrees, I would use this multiplication because the degrees are on the bottom and they would cancel with whatever you have. If you had something in radians, I would multiply by this because then the pi's would cancel out and you'd be good on that. And then just multiply straight across, reduce your fractions, and you'll have your final answer for that. And that's all there is to that. And then the last thing from this particular section that was kind of useful is arc length. And there are a couple problems like this on your test. I'm not going to make it hard, but you need to know that the arc length, S, which means the length of the curve on the outside. Would you agree? That's what that means. Remember, that's been a long time. It's really simple. It's just R, the radius of your circle, times the angle that is measured out. But your angle has to be in radians. On your review assignment and probably on your test, I'll probably give you one problem where I give you the angle in degrees, which means you got to do what first? Convert it to radians so you can actually use it. But if you find the two, the radius and the angle, then you just multiply them together and you got your arc length. And that's pretty much all there is to that. As usual, let's look at some problems and see if we can do some things. So let's see here. The first page is really about just SOHCAHTOA. Can you just find, an opposite or an adjacent? Can you do SOHCAHTOA right, basically? So we can do one of these if you want. I think it's pretty straightforward, but maybe we could do it just for completion. You want to do anything 1 through 5? Anything look interesting, or you just want to skip it because it's too easy?
Number 2.
Number 2. Nah. I wonder why you picked 2. Missing a side. Well, what can we do to find that side? Yes, we can. So maybe you do a little bit of work on number 2, but it ain't so bad. In fact, it's going to work out nice and curvy for you. So I like that. Let's go ahead and solve for the other side right off the bat. Let's do Pythagorean theorem. Now that'd be the hypotenuse. That's the C then, right? So let's see. 3 squared plus 4 squared is whatever that side is. I'll just call it C. C squared. And 3 squared is 9. And 4 squared is 16. And 9 plus 16 turned out to be 25. And when you take a square root, normally I'd say don't forget your plus or minus, but this time you can because it's a length, right? So lengths are always positive. So this side length is going to be 5. Nice clean number for you there. They're not always clean. Could be like a square root of 26 or something, but this time it's nice and 5. Okay, so now we got all the sides. So to do the rest, all we got to do is the normal SOHCAHTOA junk. So sine of this angle, by definition, is opposite over hypotenuse. So always look at the angle. Don't use any other weird angle. Look at the one you're using. This angle here, the opposite of this would be 4, correct? Hypotenuse would be 5. So this would be 4 over 5. The only thing you can really mess up in this section is maybe reducing, if there's like a 4 over 8 or something like that, or have to reduce stuff. Cosine, by definition, adjacent over hypotenuse, that'd be 3 over 5, right? And so on and so forth. Tangent is opposite over adjacent, which in our case would be 4 over 3. And that's pretty much it. And then after that, you got the 3 below it, cosecant, secant, and cotan. I'm putting them in the same order as sine, cosine, and tangent. So cosecant, and hopefully we know this by now because we've done it for a long time. Cosecant is sine flipped, right? So sine's 4/5, so cosecant is 5/4. Secant is cosine flipped, and cotan is tan flipped. So flipping all those, here's my answers for this particular problem. And that's all there is to the first sheet. Okay, the entire first page is just checking that you understand what SOHCAHTOA is. And you know which reciprocal ones are flipped and how to flip them. So pretty easy, right? I don't think that's bad at all. And if you flip the page, let's see what else I got here. 6 and 7 are the arc length things we just went over. S is r theta. Which one is a trick? 6 or 7? Why is 7 a trick? Because the angle's in degrees. You don't want that, right? So if you were going to do one of these problems, I don't want to actually do it because it's pretty straightforward. But again, S is r theta. And if you were doing 7, for example, then r would be 20, the radius of the circle, correct? Theta would be, we'll get you started. Let's practice converting while we're here. What is 60 degrees? Well, let's convert it over and see what it is. Don't forget to do this on the test. Don't do 60 times 20. I'd be mad. The conversion's what? Pi equals 180, correct? So where's the pi go? Pi's on top. Very good. Yep. And the 180 has to be on the bottom because the degrees need to cancel out. And if you multiply straight across, 60 times pi is just 60 times pi. Do not type in your calculator. Do not do a decimal because pi is just something that goes on forever. Do some weird thing. Kind of ignore the pi's actually, and just keep the pi there at the end. Like 60 over 180. Could you reduce that? I think 60 goes to both of them, don't they? 60 goes to that 1 time. 60 goes to that 3 times, right? So it reduces to 1/3. But don't ever write 1 times something. Don't write 1 times pi. That would irritate me too. It's like writing 1 times x or 1 times 6. It's like, why would you write 1 times something? It's dumb. So that answers pi over 3. So if you were going to do the whole thing, and I guess we're already there, let's just finish it up. If S is r theta, and r is 20 feet, right? And theta now is pi of 3. Make sure you use the radian version of it. Well, if you multiply straight across, that's 20 pi over 3. 20 over 3 does not reduce, so that's our final answer, 20 pi over 3. And that is the length of the curve on the outside, so the appropriate unit for this would still be feet, but I took the liberty of putting the unit on the answer for you, so you have to think. You're welcome. Makes sense, right? Okay. And then before we go on, 8 through like 14, I'm putting a lot of problems on here that are just like what we learned in the warm-up. Can you just solve some side of a triangle? That's it. And even though we haven't practiced that to death, you got your SOHCAHTOA down, you should be fine. So I think we should practice one of them. Just one more time as a freebie. Anything 8 through 14 look interesting? 9? What's so scary about 9? Oh, let's see about 9. Okay. Got a little weird thing here. All right. Number 9, let's do this. You're looking for this side x. The directions say solve for x. You don't need to solve for everything. You just need to find this side x. This side is 5.4. And this little angle in here is so tiny that they had to draw an arrow. But it's a 29-degree angle in there. So again, if you're going to apply SOHCAHTOA to solving problems, just look at the side you want. What is the side you want? It's opposite the angle, would you agree?
Yes.
And what side? You got to tie it to something you know. What side do you know? What side is that 5.4? Adjacent. So O and A, which one would you dive in with? Yeah, agreed. So you go in with tan. Tan of this angle is by definition the opposite side x over the adjacent side of 5.4. Just make sure you don't go too fast. I know you guys know this stuff. Just make sure you're very careful about this is the opposite, this is the adjacent. The only thing you can do is have a brain meltdown for half a second and think of the wrong side as being the wrong side or something like that. All right, I think it's pretty easy to solve for x from here. Why is x not by itself? Because it's divided by 5.4. So let's get rid of divided by 5.4 by multiplying by 5.4. Multiplying this side by 5.4, you have 5.4 times tan of 29. And on the right side, the whole reason you did that was because if you multiply by 5.4, the divide by 5.4 is gone. So your answer is whatever this is when you type in your calculator. So you get your calculator out and type it in and see what the answer is. That sounds reasonable to me. Yep, 2.99. So that's your answer. In the slot, you write 2.99 down. You're good. That's all there is to it. Pretty straightforward. That whole section's pretty straightforward. Now, I didn't formally teach that, so I don't want to leave you out in the wind, but it makes sense, right? It's not that complicated. So hopefully you got those problems under your belt already after a quick 5-minute lesson. And you should, because you've been doing SOHCAHTOA so freaking much that everything should be pretty straightforward. Questions on that? All right, moving on to the review then. The next section after 11.1 was 11.2. And this was about generalizing this stuff. Now, how do you generalize this? We don't want to think of them eventually. We want to grow up a little bit, stop thinking about opposites and hypotenuse and things like that. We want to start thinking of them as just on some circle of radius r away. And if we could know the coordinate of where we are, the x, y coordinate and the r, we could actually redefine all these 6 trig things in terms of x, y's, and r's. Now, I don't want you to memorize that. In fact, I don't even put that on the board for your test. I always put up equations, and I didn't put that on the board. What I did put on the board was this picture. Okay, this picture tells you the exact same thing as before. If you draw a little triangle inside of here, this side length would be, and here's some coordinate up here, say, oh, I don't know, x comma y. Well, if this is x, then wouldn't this distance be x? And wouldn't this distance be y? And if you're on a circle, then r stands for the radius, right? The distance from the center on the outside. So you can redefine all 6 trig things, not in terms of opposites and adjacents, but in terms of x's, y's, and r's. Looking at the picture, those 6 definitions are buried inside of it. Because you know sine is opposite over hypotenuse, correct? And on this picture, the opposite side is y, right? Hypotenuse is r. So your definition for sine now is y over r. Similarly, for cosine, its definition is adjacent over hypotenuse, which on my picture would be x over r. And so on and so forth. Tan, opposite over adjacent, would look like y over x on this particular picture. And then again, if you know the 3 which are flipped, cosecant is sine flipped, so that's definition to r over y. Secant is cosine flipped, so that's r over x. And cotan is tan flipped, so that's x over y. So there's the 6 definitions, not in terms of opposites and adjacents, but in terms of where I am on a circle, any circle, the x coordinate, the y coordinate, and the radius away from the center.
Is that going to be on the board?
The only thing I'm going to put this on the board, yeah, not this. I expect you to understand where this comes from. This comes from that right there. So if you want to memorize all these, be my guest, but I'd rather you remember they come from this picture. Sine's opposite over hypotenuse. Well, that's y over r, right? So if you know what SOHCAHTOA is, and you have this picture, then automatically you have all the other 6 kind of already figured out, and you don't have to memorize them. And that's what you should probably do. You know, math isn't about memorizing 80,000 formulas. It's about memorizing one thing and understanding how it generalizes to everything else. So that's what we're going to be doing here. Now, if they don't give you the radius that the circle's on, say they gave you a point out in space of x and y, how could you find the radius from this little boxed equation here? That'll be on the board too. R is the square root of x squared plus y squared. So that's all there is to it. If they give you an angle, though, some kind of pretty angle like 30 degrees or 3 pi over 2 or something that's on your unit circle, use your unit circle, because on the unit circle, they give you all the x, y coordinates as you go around. You remember that stuff? And what's r on the unit circle? It's 1. So you got everything you could possibly need for these definitions, x, y's, and r's for any angle that might come up. And all you got to do is apply them, and that's pretty much it. There'll be nothing on there about reference angles or any of that nonsense. They don't do we worry about that stuff. Okay, let's review this, because this has been a while. I want to make sure we got this down. So 15 on, let's see, 15, I want to do 15, yeah. Let's do any 15 through 18. 15 through 18, they all give you just an angle. And when they give you an angle, you should be thinking, I'm going to bust out my unit circle. That is the key to this entire problem set in here. They gave me an angle. Is it on my unit circle? Yes, I should use my unit circle. So pick anything, 15 through 18.
18.
Okay, 18 says 7 pi over 6. And I'm testing lots of things about this particular angle. All right. First things first. The first thing in this section asks for is 2 coterminal angles. So you said it before, what's coterminal mean? You add or subtract all the way around, right? But we're in radians. So we got to add or subtract 2 pi. Exactly. Okay. So I got to add or subtract 2 pi to this thing. And whenever you add or subtract a fraction, by now you should know we need a common denominator. So the 2 pi one probably means a 6 on the bottom, right? So we'll multiply top and bottom by 6. That would give it equivalently being called 12 pi over 6. That's still 2 pi. And the reason I do the plus or minus is because it's the same thing when you're add or subtracting fractions, right? If you add or subtract either way, you get a common denominator. If you add them together now, add the tops, what's 7 pi's plus 12 pi's? All right, so one answer would be 19 pi over 6. Make sure it's in radians. If I gave you radians, you darn well better give me something in radians. Number 15's in degrees. You would give me something in degrees. 16's in radians. Give me things in radians. Make sure you give it to me in the right format. But there's another slot because I want you to do the plus and the minus. What's 7 pi minus 12 pi? negative 5 pi. So the other answer would be negative 5 pi over 6. So there's my two coterminal angles. Any questions over the coterminal stuff? It'd be the same thing with degrees. We'd just be doing 360s, right? Okay. Now the next thing they want you to find with this angle is degrees. So we actually want to convert to degrees. There's of course two ways you can do this. Maybe it's on your unit circle. 7 pi over 6 on your unit circle? Okay, what's it say it is in degrees? Well, there's your answer. You could do that. Or if I gave you some freak thing that wasn't on there, you'd have to convert it. And I'll practice converting one more time because remember the conversions, pi is 180, right? This time I want the pi on the bottom. That way the pi's will cancel out. And if you multiply straight across, or actually cross reduce. Anybody know what 180 divided by 6 is?
30.
Anybody know what 30 times 7 is? And isn't that what it said on your unit circle? Say 10, yeah. So no matter how you look at it, whether you convert it from scratch or you just look it up on the thing, this in degrees would be 210. Any question over how we're converting back and forth? All right, and then they get into the hardcore stuff. They want the sine and the cosine and the tangent of all this stuff. But here's the definitions of sine and cosine for all this stuff. So I assume you got your unit circle out, right? I need three things in these equations, x, y's, and r's. If you're looking at your unit circle, automatically r is 1. And at 7 pi over 6, what's the x coordinate?
Negative 3.
Negative square root of 3 over 2?
Yeah.
Okay. What's the y coordinate?
Negative 1.
Okay. So I got x, y, and r. I got all 7 definitions here I figured out. In fact, when you take your test, maybe the first thing you want to do is translate this picture into all these equations so you just have it, but you don't have to. All right, here we go. So if they say sine, you just got to be patient with your fraction work here. Sine is y over r. So that'd be negative 1/2 over 1. What's anything divided by 1? Itself. So I guess sine is negative 1/2. By the way, you could check this. Do you have that graph of sine out? Get that out too. If you go to the sine graph and go to angle 7 pi over 6, guess what it says the value is there? Oh, look at that, it agrees. So that's where this thing, that's where the graph is coming from. It's coming from doing all this stuff. So you can check it real quick. How about cosine? Cosine by definition is x over r. That'd be this weird root thing over 1, so just the weird root thing. So negative square root of 3 over 2. And again, if you want to check it, you can go to your cosine graph. And I guarantee you, if you go to 7 pi over 6, it says negative square root of 3 over 2. Does it? Okay. So like we're good. And you just keep on going with this stuff. Now the tan one is the one that's going to be rough. Because tan is y over x, which means you have to take this fraction divided by that fraction. Do not just tell me the answer is negative 1/2 divided by negative square root of 3 over 2. Don't tell me it's that. You got to go do the fraction work and clean it up. And by now, we know how to do that. Don't divide by a fraction. Multiply by the reciprocal. So instead of saying dividing by negative square root of 3 over 2, we'll say we're timesing by negative 2 over square root of 3. And as you go straight across, negative 1 times negative 2 is positive 2, correct? There's a 2 on top. On bottom, there's not much I can do. It's just 2 times square root of 3, but make sure you're simplifying. In fact, I underlined that and italicized it and bolded it. Still never makes a difference. What cancels out here?
2.
Oh, so your final answer for this is 1 over square root of 3.
No, it's not rationalized.
Now, if you go to your tan graph and look up 7 pi over 6, it does not say 1 over square root of 3. That's a fine answer. I'm okay with that. If you want to call it 1 over square root of 3, you're fine. But what they like to do is rationalize it. So this last step is optional. Remember how you could get rid of a root on the bottom? You can multiply the top and bottom by that root. And then on top, you would just have the root. And of course, on the bottom, square root of 3 times square root of 3 is 3. So that's a better answer. But if you don't want to go that far, I would be okay if you left your answer as just 1 over square root of 3. But then don't panic if it doesn't match the thing on your graph perfectly, okay? Maybe they just massaged it and made it a little bit different. Any questions over that right there? Fine. Now all we gotta do for the other three is flip them. So cosecant, I'm not gonna do the r and y stuff again. Here's my answers. Let's just flip it. Cosecant sine flipped. So -1/2 flipped is just -2. Don't write -2/1. Don't write divide by 1. I'll be mad. Flipping cosine will be secant. Sweet. And then lastly, to flip tan, doesn't matter which version you flip. I'll just go with the one you probably would have answered, 1/√3. If you flip that, just √3/1 or √3. You can also check these with your calculator too, by the way. If you wanted to go check this, what angles are they given, 7 pi or 6? You'd have to make sure your calculator is in radian mode because those are radians, correct? And then if you want to, you could type in tan of 7 pi over 6, hit enter. They give you out some weird decimal, 0.577. You'd say, okay, what the hell is that? And then you go check what's 1 divided by √3. Guess what that would say? 0.577. And it'd be the exact same thing, and you can be sure that you're okay. You might not want to do that though, because if you go to radian mode, make sure you go back to degree mode. You got to be really conscious of what mode your calculator is in, so be careful about that. Questions over anything from there? All right, now 19 through 22 is not any worse. It's just that they're not giving you an angle, they're giving you a random point in space. So you can't use your unit circle on these, but you can still, if you're given a point, you got an x and a y, don't you? Oh, and we have an equation for r, don't we? It's √of x² + y². So it's the same thing. We just got to work for it and figure out what r is, but then we can plug in the definitions again and work out. So anything that you want to do from there, 19 through 22, anyone? Doesn't matter, they're all the same. Anyone? 20, done. Okay, last example of the day, number 20. -5, -12 is our point. Again, as a concept, you don't have to know this. But what they're saying is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What they're saying is this point lies on some, that's a terrible circle, but it lies on some circle at some angle here. And this circle has a certain radius to it, correct? So right off the bat, x is -5, y is -12, and like you said, 13. This will be on the board. Yes, it's 13, but hang on. Slow down, slow down. X² + y² under the root. So you take the time and x², -5² is 25. Y², you type in -12². Make sure you put things in parentheses when you square them right. Don't. It should always be positive. It should be square. It should always be positive. -12² would be 144.
169. 13.
Slow your roll. Don't you hesitate?
I do, but I don't like it. I'd rather do this.
That's dumb. Okay, so you got your x, you got your y, and you got your r. So now you just go back to your definitions. It's the same thing. Now you're out of the woods. And you do the same thing you do with the unit circle. You just write them down. So sine of this angle, not that I even care what it is, but the sine associated with this angle is going to be y over r again. So that's going to be -12/13. I don't see any weird roots this time, so there won't be a lot of weird cleaning up to do. Let's see, cosine's x over r, so -5/13. Tangent, y over x. So that's going to be -12/-5. Don't say -12/-5, because you should know a negative divided by negative is positive. So please say 12/5. And then we just got to flip them for the other three. Cosecant is sine flipped. 7 -3/12. Secant is cosine flipped. -13/5. And cotan is tan flipped. So 5/12.
Why do I literally remember doing this exact problem?
I think I stole it from my work from previous years.
Probably.
And that's it. Okay, so that's like the first half of the whole unit. In retrospect, it's not that bad. Would you kind of agree? How do we feel about this stuff? You guys think it's going to be okay? Any questions over anything? Bree says it's not going to be okay. What questions you got? You got questions? Tell me. Anything at all? Anything we did?
No, it doesn't, go in the brain.
Doesn't go in the brain?
It's just so.
How do we fix that?
Get a better brain.
Brain transplant.
Brain transplant. Okay, fine. Well, anyway, that's about the first half of your review. Like I said, tomorrow we'll go on and start checking, we'll continue to check Lawrence and learning goals. I'll only get to a few of you today. But we'll start on 11.4 today, tomorrow, graphing, sine, and cosine. Try to work on your review assignment a little bit. I know you got 11.7 still on your plate. So get that taken care of as well.